Hello everyone and welcome to this video.
Let's dive into Python's core data structures. These are the building blocks for handling data efficiently. We'll explore lists, tuples, sets, and dictionaries, each with its unique characteristics and use cases. Let's start with lists. They're versatile and can hold different types of data. We'll see how to create and manipulate them. Here, we're defining a list of numbers and printing it out. Lists are great for storing sequences of items. This list contains integers, showcasing how lists can store multiple items in a single variable. Now, let's create a mixed list with different data types. This flexibility is one of the strengths of Python lists. Our mixed list includes an integer, a string, and a float, demonstrating the diversity of data types you can store. Here's a list of fruits. We'll use this to explore various list operations. Let's access elements in the list. Here, we're retrieving the second fruit, which is banana. Now, let's slice the list to get a subset. We're getting all fruits from the second position onward. To find out how many items are in the list, we use the len function. It returns the total count of elements. Let's add a new fruit to the list using the append method. This adds orange to the end of the list. We can also insert an item at a specific position. Here, we're adding kiwi at the fourth position. To add multiple items, we use extend. This method appends each element from the iterable to the list. Let's see how many times grapes appears in the list using the count method. To remove an item, we use remove. Here, we're taking out apple from the list. Sorting the list alphabetically is easy with the sort method. This arranges the fruits in order. For numbers, we can sort in descending order by setting reverse to true. To clear all elements from the list, we use clear. This leaves us with an empty list. Lists can also contain other lists, forming a matrix-like structure. This is useful for representing grids or tables. Here we have a 3x3 matrix. We can access and modify elements just like in a regular list. The matrix is a grid of numbers. We accessed and modified specific elements to demonstrate its flexibility. Next, let's talk about tuples. They're similar to lists, but immutable, meaning their elements can't be changed after creation. Here's a tuple of numbers. We can find its length using the len function. Tuples can be concatenated to form a new tuple. Here, we're adding more numbers to the original tuple. We can also repeat tuples using multiplication. This creates a new tuple with repeated elements. To find the index of an element, we use index. This returns the position of the first occurrence. The count method tells us how many times a specific element appears in the tuple. Now, let's explore sets. They're collections of unique items, perfect for operations like union and intersection. Here's a set of numbers. Sets automatically remove duplicates, ensuring all elements are unique. To find the union of two sets, we use the pipe operator. This combines all unique elements from both sets. The ampersand operator gives us the intersection, showing elements common to both sets. We can also find the difference between sets, which shows elements present in one set but not the other. To add an element to a set, we use add. This ensures the element is unique within the set. Removing an element is straightforward with remove. This takes out the specified item from the set. We can check for membership using the in keyword. This tells us if an element is part of the set. Finally, let's look at dictionaries. They store data as key value pairs, allowing for fast lookups and updates. Here's a dictionary representing a person. It contains keys like name, age, and city. To access a value, we use its key. Here, we're retrieving the person's name. Updating a value is simple. We assign a new value to the key, like changing the person's age. We can add new key value pairs easily. Here, we're adding an email address to the dictionary. To remove a key value pair, we use del. This deletes the specified key and its associated value. Checking for the existence of a key is done with in. This tells us if a key is present in the dictionary. To get all keys, we use keys. This returns a view of the dictionary's keys. Similarly, values gives us a view of all the values in the dictionary. The items method returns a view of the dictionary's key value pairs, useful for iteration. In this data scenario, we're analyzing student performance using a list of dictionaries. Each dictionary represents a student. We've created a list of students, each with their name, grades, address, and courses. This structure allows us to manage and analyze student data effectively. Let's calculate the average grade for each student and add it to their dictionary. We're iterating over each student, calculating their average grade, and adding it to their dictionary. This gives us a quick overview of their performance. Now, each student has an average grade, making it easier to compare their performance. Let's find out which student has the highest average grade. We're creating a list of average grades and finding the maximum value. This helps us identify the top performing student. Isabel stands out with the highest average grade, showcasing her excellent performance. Next, we'll store each student's courses and grades in a dictionary for better organization. We're using the zip function to pair each course with its corresponding grade, creating a dictionary for each student. Let's compile a list of all unique courses offered. We're collecting all courses from each student and using a set to filter out duplicates, resulting in a list of unique courses. Now, let's count how many students are taking each course. We've initialized a dictionary to keep track of course counts, starting with 0 for each course. Our course count dictionary is ready to be updated with actual data. We're iterating over each student's courses and incrementing the count for each course in our dictionary. Let's visualize the course enrollment data with a bar chart. We're using Matplotlib to create a bar chart, showing the number of students enrolled in each course. This visual representation makes it easy to spot trends. The bar chart reveals that history is the most popular course, while others like philosophy have fewer students. Finally, let's find out how many students live in San Francisco. We're counting students based on their address, specifically those living in San Francisco. This gives us insights into student demographics. We found that 4 students reside in San Francisco, highlighting the city's representation in our dataset. Understanding Python data structures is crucial for any aspiring data scientist. They form the foundation for efficient data manipulation and analysis.
Thank you so much for watching this video. Don't forget to subscribe my channel and see you next time.